All right, awesome. So thanks everyone for your attendance today. Today's webcast is titled Data Lake to Snowflake Migrations. We'll talk about the why and the how to migrate your S3 data lakes into Snowflake. A few logistical items. We are recording this call and we'll be sharing that recording after we wrap up the webinar. Usually takes about a day or so for the recording to be made available. And we'll make sure we send that out to all that attended. We do have all the audio lines muted for recording quality purposes, but we do want to encourage interaction. So if anyone has questions, the best way to get those questions over to us is through the Q&A function of Zoom. You'll see a Q&A button in Zoom down towards the bottom usually. And if you click on that, it'll open up a pane. You can ask any and all questions that you have, and I'll be keeping my eye on that as we go through the session today. I've got my questions over on my second monitor. So if you see me looking off to the left of the screen, that's usually because I'm keeping an eye on the questions. And I'll do my best to kind of answer those in real time as they do appear, especially if they're relevant towards a topic that we're discussing at the time. But any questions that I don't get to in real time, I'll make sure we have a chance to answer towards the end of the session today. And I'll stay on the call for as long as needed in order to make sure that anyone and everyone's questions are answered. So definitely do want to encourage feedback and interaction. Also, when you leave the webinar today, a survey will pop open, which is another great way to pass along feedback. We'd love to hear any and all feedback that you have. If you have to leave the session early, that survey should pop up. Anyone who does stay on to the end as well, you'll get the chance to fill out the survey form and provide any sort of feedback that you might want to give based on today's content or any future content that you might like to hear from Upsolver. So with that said, I'll go ahead and jump in. I'll start with introductions, and I'm going to introduce myself, but I'm also going to open up a poll to learn a bit more about the audience that I'm speaking to today. So that poll should automatically open in your Zoom console, and I'd appreciate as many of you replying to that as is possible. Allows me to kind of learn who I'm speaking with today and possibly even tailor some of the content based on some of the feedback that we get. As everyone kind of responds to that poll, I'll introduce myself. My name is Jason Hall. I'm a solutions architect at Upsolver. I've been in the data space for about 18 years now. I started my career, much like many of you likely, in production support for a company that was a data backup and recovery solution. Eventually bounced around in various data roles. I was a DBA for a little while, did some development work, and eventually came over to the business intelligence and data analytics space, and then kind of moved over to kind of the big data lake, data warehousing space where I sit today. Been at Upsolver for a few years now, and it's been kind of a fun data journey. I do live just north of Boston, Massachusetts, in a town called Reading. Bright and sunny today, but freezing cold. So if you see some sun poking through my windows, that does not imply warmth. It is freezing, but I'll take the sun anytime I can get it. And I always kind of lead in with a fun fact. Those of you looking at my backdrop notice I'm a pretty big sports fan. Specifically, baseball is probably my first love. I have been to 29 out of 30 Major League Baseball stadiums. I used to be able to say that I'd been to all 30, but the Texas Rangers moved stadiums a few years back, and I haven't had the chance to visit that one yet. So definitely looking forward to the opportunity to do that, and again, be able to claim that I've been to every Major League Baseball stadium. So that's a bit about me. Let me go ahead and take a look at some of these poll responses. Cool. So if we look at the first question about data sources, the majority of you are working with file-based sources, and that certainly makes sense given the topic of today's webinar. We're talking about data lakes. Data lakes are typically built off of files, and files make up the most widely used data source. There are, though, a lot of you working with relational databases. Not surprising, maybe surprising in volume, but a lot of you working with PostgreSQL and Microsoft SQL Server. A lot more Oracle folks on this session than the prior session that we did. So I'm not sure there's a conclusion there, but a bunch of Oracle, bunch of Mongo, wow, it's a pretty even distribution, to be honest with you. I'll share this data with you, by the way, once I get through it all and give everyone the chance to answer. I guess another interesting point, almost half of you are working with streaming sources. So we've definitely seen an increase in the adoption of real-time event streams, and that's kind of indicated here by the response to this poll. So that's encouraging. So pretty even distribution, but definitely a leader in the clubhouse are files, and kind of an interesting note at the adoption of streaming sources. If we look at where data platforms are being run, a lot of AWS, unsurprisingly, not as much Azure as I was expecting. I know there's a big Microsoft conference going on as we speak, so maybe all the Microsoft folks are over in the Azure conference. And still about half of you are running infrastructures on premises. So a little bit surprised at that number. I didn't expect it to be that high, but I certainly know customers are kind of in the middle of their cloud migration journey, and it's kind of indicated by the fact that so many of you are still running environments on-prem. If we look at data volume, I usually scroll to the bottom because I'm just kind of curious about how widely we're seeing large data volumes. So not a huge number, but there are a few of you running data volumes in the hundreds of terabytes to petabyte scale. So certainly are starting to see some very high scale data volumes out there. Majority of you seem to be in kind of the hundreds of gigabytes to tens of terabyte scale. And then in terms of this largest single data source, I'll kind of look at those answers offline. I'm always curious just to hear kind of who in the audience has the largest data source out there. So I'm going to go ahead and end the poll. I do appreciate everyone sharing that with us. I'll share the results with all of you so you can see for yourselves and kind of see what you answered along with your peers. So I do appreciate everyone taking the time. That's always interesting feedback for myself. And again, my takeaways there are certainly a lot of file-based sources being worked with out there, an increase in the number of streaming sources, and several of you out there working with data volumes into the, I'll say, hundreds of terabyte scale ranges. All right, so that said, the topic today is to discuss data lake migration, specifically into data warehouses. Given the titling of this session, we're going to be talking a lot about Snowflake today, but I will just kind of emphasize the general concept here is kind of moving a self-managed data lake into a managed data warehouse. And so even if Snowflake is not your potential target, all of the concepts here are going to apply to any warehouse-based architecture. Right? And we're going to take the agenda today and split it into two components. I'm going to try my best to make it about half and half. We'll spend the first half of today's session discussing the why. So why did data lakes become popular in the first place? What sort of challenges exist in data lake management, and what makes data lakes successful or unsuccessful within organizations? And then why do data warehouse platforms like Snowflake provide a solution to some of those challenges? So whether you out there are considering a data lake migration into a data warehouse, or are just getting started with a data project and not sure if a data lake or a data warehouse is right, we'll spend the first half of this session talking about that why context, right? Why are customers considering or looking to migrate their data lakes, their self-managed data lakes, into data warehouses? And then we'll spend the second part of this presentation discussing the how, right? So how do we actually do that migration? And we'll briefly touch on kind of some of the mechanisms that are available within the data warehouse platforms themselves. But then we'll also get hands-on with the Upsolver solution and show you, not only show you, but really ask you to follow along with doing your own data lake migration. You know, we call these workshops. It's really an encouragement to not only watch a demo, but actually follow along with the demo. We'll get you signed into an Upsolver account. We'll provide you with connectivity details to a sample data lake, as well as a Snowflake connection. And you'll be able to kind of get a feel for the Upsolver experience by actually going through a use case where we migrate data lakes into a data warehouse. So that's kind of the objective and the agenda that we'll lay out today. Again, I know I have noticed a bunch of people kind of joining in before I did my intro. I do want to encourage questions. You'll see a Q&A function in Zoom. So anytime a question does pop into your head, feel free to send that over our way. I'll do my best to keep an eye on that in real time. And any questions I don't get to in real time, I'll answer at the end of the call. So we'll kind of start this context by going back a few years. We'll go back, 5, 10, 15-ish years to when the majority of production data infrastructure were all on premises, right? And at that time, and this part of it actually hasn't changed, but especially at that time, data warehouses were extremely expensive. And they were expensive both in infrastructure cost and license cost, right? And when I talk about infrastructure, I'm talking about kind of infrastructure in the traditional sense: servers, storage, racks, data center space, networking, right? All of that was really expensive, but then the licenses to run on that infrastructure were very expensive as well. And this continued to be the case even as infrastructure kind of started being decoupled, right? We often talk about decoupling in terms of compute versus storage. And even in the early days of that decoupling, where we started to have like NAS and SAN devices to where the disks weren't in the servers themselves, we were still paying a lot for storage, right? Hundreds of dollars per gigabyte, I remember, was a number thrown out not even that long ago, once you started thinking about these very high-end, very high-performance SAN devices. And all of this resulted in a really difficult reality where companies were trying to become more data-driven, right? They were trying to make more of their decisions based on data and analytics, but the upfront cost needed to provide that data was so high, it was kind of stopping a lot of projects before they even got started, right? Our management team or our leadership team says, we need to start this new data analytics project, but it's going to be millions of dollars in infrastructure and license costs before we even know if that project is going to return any investment or any benefit to our business. So we saw all these kind of data projects get stuck in that justification phase, right? I know what I want to do. I just don't know if it's a good idea, and I'm not willing to spend all this upfront money to make that happen, right? And so this whole idea started to come around, like, what if we could dramatically reduce the upfront cost in a data project by leveraging more inexpensive commoditized hardware and less expensive open source software for that type of big data management, right? That's kind of this theory started, tens of years ago around, we want to do this data analytics project, but without the upfront cost. How might we go ahead and do that? All right, and that's kind of where the early data lakes started to take shape. They weren't even, I never even heard them called data lakes at the early stage, but that's effectively what they were, right? We can use technologies like Hadoop file system and Hive metastores. We can start to store huge, massive volumes of data on commodity infrastructure and storage with fairly low-cost software on top of it, and start to manage and process data in the terabyte scale without the traditional high cost or that high cost barrier to create that sort of data volume or manage that sort of data volume. I actually remember this image I didn't take this picture, I found it online, but I remember this was about 12, 13 years ago, going to a large hardware manufacturer in Texas. And they were walking us through a data center, and they walked us through one room of the data center that had about this much infrastructure in it. I remember like 4 or 5 server racks, each rack full to the brim with a few blade servers, but most of it was storage. And they told us that that data center was running one Hadoop cluster, right? And it was petabyte scale, but it's just a massive amount of infrastructure to run a single Hadoop cluster to do some big data processing. So even though the cost for this infrastructure went way down, the complexity of the infrastructure was huge, right? Spinning up all those different clusters was difficult. How do we manage all that data? The software was in the early, kind of the infancy of how Hadoop was managed, how Hive was used. And so the challenge was kind of shifted from upfront cost and infrastructure and licensing and more into complexity, right? Now, in comes the cloud, right? So if you think of, and this is just the general cloud conversation, but that image of the data center sitting in your own office with lots of servers and racks that you had to manage and provision yourselves, the cloud started to take shape, and the cloud effectively gave us theoretically unlimited access to inexpensive storage. And it gave us theoretically unlimited access to easily scalable compute. We were no longer bound by the constraints of our own data center. We could provision storage and compute as needed. We could scale it up as high as we needed to go. And the cost was manageable, right? It was contained, I like to say. So it was really kind of when cloud native data lakes started to take shape that these projects started to become more realistic, right? So this solved the problem of at least infrastructure, right? Compute and storage needed to drive large-scale data projects. We can now store terabytes, even petabytes of data for analytics without the cost and overhead of managing our own data centers. But software continued to be a challenge, all right? And I grabbed the simplest architecture diagram I could find of what a data lake architecture looks like. This is an example specific to AWS, but each data lake vendor has a similar diagram. And even the simplest architecture diagram has about 6 or 7 services all needed to build and operate a data lake infrastructure. Right. If you look at over on the left, you've got your source data. In this example, it's just a single RDS database. And most data lake architectures, you're going to have lots of data that you're reading from. But you need an ingestion service that's going to get data into your data lake. Right. The data lake itself is a combination of S3, where you actually put the data, and some sort of cataloging or metadata layer, right, where you describe that data and make it discoverable and queryable. Right, you're going to have some combination of ETL or ELT services, be it AWS Glue, Spark, Kinesis Firehose. You're going to have some combination of services that are going to ingest, transform, and catalog data to make it usable. You're going to have some query layer, like maybe AWS Athena or Redshift Spectrum, that can then connect to that catalog and run queries against it so that you can perform analytics against it. Right, you're going to have some kind of security layer on top of this to make sure that the data is protected and we kind of know who has access to it and who should have access to it. You need some sort of orchestration layer to actually run all the code needed to make this whole data lake infrastructure work, right? So the reality is, even if we kind of solve the infrastructure problem, we still have a software complexity problem in order to make, a data lake successful and kind of deliver on its perceived value. And if I'm going to kind of summarize the types of software components needed in order to function a data lake, there's typically a metastore catalog, right? That's that in AWS, it's the Glue data catalog, but it's some metastore catalog that describes the data that we're storing in our lake. We need some process and service for ingestion and transformation, right? We don't have a data lake unless we can get data into it. And in most cases, raw data is not immediately queryable. There may be some analytics that you want to do against raw data, but in most cases, you're going to have to do some level of transformation to make that data available for analytics, right? So you need to have an ingestion and a transformation component. Security and access control is a big one. It's pretty easy to just take an S3 bucket and throw a bunch of data in it. But once we start to consider what is that data, does it include PII? Is it sensitive in any way? Who should have access to it? Who shouldn't have access to it? And then kind of divvying that out by data set, by who's querying it, by what query is running. That's a huge component of a data lake architecture. And then finally, you need a solution for querying that data, right? And these are kind of the bare minimum software components needed in order to make a data lake project successful. There's lots of others that you could add on top of this, depending on the use case and requirement. And I kind of put this in a table form. I'm not going to spend too much time here on this table, but just as an example, right, where you see data warehouse on the left, data lake on the right, and I kind of spoke in both general terms as well as in a Snowflake versus AWS example. If you look at like a metastore component, Snowflake manages their own metastore. It's not something you really even have to think about. It's just there, right? In a data lake, you've got AWS, you've got a Glue data catalog or some sort of Hive metastore that has to be managed as a part of that data lake project. On the ingestion and transformation side, most data warehouses either have their own data ingestion and transformation services, or there's a very well-defined ecosystem around ELT or ETL, right? I put in Snowflake as an example. Snowflake has lots of ingestion services, Snowpipe being the most commonly used. There's also dbt for data transformation. And while dbt isn't necessarily part of Snowflake, dbt ends up effectively writing Snowflake code that runs against Snowflake to do data transformation. So it's pretty well integrated into the Snowflake ecosystem. In the AWS stack, you've got services like Glue ETL, you've got Kinesis Firehose, you've got Spark, kind of all separately managed services. Security and access control, Snowflake includes tons of data governance capabilities in order to set up, different permissions on who can do what and against what inside of the platform and ecosystem, right? In a data lake, in AWS world, a lot of that is IAM, right? And IAM has become kind of a four-letter word, even though it only has 3 letters to it in the data space. Managing IAM, especially at enterprise scale, is a job in and of itself. And that's kind of a separately managed component within most data lake architectures. Right? And then finally, in querying, there's lots of options, but effectively in querying a data warehouse, you're using the data warehouse. In a data lake, you're using some external service like Athena, Presto, Trino, Starburst, there's a bunch of them out there, but all kind of a separate component used to query a data lake. So because of all this, right, again, kind of centering back on the why, right? Why did data lakes take shape in the first place and what challenges existed in managing them? We kind of end up in this gray area where many data lake projects were unsuccessful. Right, we started them at the promise of a very low cost, very scalable infrastructure for processing large volumes of data. Now, I do want to emphasize the fact that I know of many successful data lake projects, right? This is not to say that data lakes are inherently going to fail, like data lake projects are going to fail. There are many companies who are very successful in data lake implementations. And if you're going to kind of draw, 4 different questions that I like, or if you're going to kind of propose 4 different questions to an organization that will predict whether or not their data lake project will be successful, these are a good 4 questions to start with. A coworker of mine, Roy Hassan, kind of outlined these in a LinkedIn post, and I think they do a good job of kind of summarizing what data lake projects are likely to succeed and what are likely to fail. The first question is, do you, and when I say do you, I'm talking about your organization or your company, do you have the resources, both people and products, with data lake expertise available to build, maintain, and scale a deployment, right? Data lake projects without a staff with experience in data lake projects, just inherently not going to work, right? It takes a specific type of expertise to make these successful. Now, pending one, right? If you have the people and products needed to make a data lake project successful, do you have the time to actually see it through, right? Data lake projects are not plug and play. This is not, a data lake project on large scale data is not going to be implemented in weeks to months, probably not even quarters, and maybe not even years. Right? Because of all the moving parts and all the components that make up a data lake infrastructure, generally speaking, these projects take months, quarters, years in order to be successful. And if a company has a very short-term objective for a particular data product or data project, it's probably not going to fit inside of a data lake implementation. Third is probably the most concrete, but I often see this overlooked, at least at the early stages of planning. Does the value layer, and value layer referring to like, what are the analysts actually using to provide their dashboarding and reporting, business intelligence, machine learning, whatever it might be? Does that fully support analytics against data lakes, right? If your leadership team is using Tableau for BI, does that platform have the ability to analyze the data that you're preparing and managing in a data lake? I've seen far too options. I've seen examples within organizations where customers build out data lakes. They get all of their data stored in S3. They catalog it properly. Everything's efficient and optimized. And then they end up having to send that data out to a Microsoft SQL Server database just so a front end can actually report on it. right? Kind of defeats some of the purpose of maintaining the data lake. And then lastly, kind of, do you have real-time streaming sources that collect and store, multiple terabytes of data, sometimes even many terabytes of data per day, right? Those types of questions, and if you answer yes to those, a data lake-based solution could very much be a good fit, right? I think you're likely to be successful if you have people, if you have time, if you can query against data lakes, and if you have large-scale streaming data volumes. If you answer no to those questions, though, I think a data warehouse is probably a better fit, right? Some sort of managed service that offloads the complexity into the data warehouse or the data lakehouse-based ecosystem. Right? So that's kind of the why, right? Why do customers build data lakes? What challenges exist in managing data lakes? And why might a customer consider migrating into a managed data warehouse, right? And again, to offload the complexity and just kind of be able to deliver data projects faster and more efficiently. So how do we actually do the migration, right? So the general, very oversimplified workflow of a data lake to data warehouse migration starts with kind of like a modeling exercise, right? This isn't so much modeling in terms of building out star schemas, so that could be a part of it, but it's the modeling of taking source data that exists in files and mapping that to a table within a data warehouse, right? And this mapping involves everything from data type mapping, right? A lot of source data lake files do not have strongly typed data types, right? Could have just strings and numbers, but strings of varying lengths and numbers of different precisions. Could have date timestamps in a variety of formats. So the first kind of step is to just consider the data that we have in our data lake files and model those into columns and specifically column data types within our target warehouse. And something that has to be considered as a part of that modeling is how you're going to work with nested or complex data types, right? Many data lakes are built off of semi-structured data, right? Or even if it's structured, it might be nested, right? A concept that doesn't exist as readily in the relational world, where a single parent field could have multiple child fields, and there could even be array elements within some of these fields. So how are we going to consider working with those semi-structured or nested data types? Snowflake does include an option, which is very commonly used to kind of, I'd say, the delay of having to make that choice, right? If we have some sort of nested structure and we're not sure how we want to model it, let's just stuff it in a Snowflake variant column, and then we can worry about it in our querying and our transformation logic. I see variant columns often overused, and they could have they could have downstream performance or complexity impacts, but it is a good option for kind of maybe deferring that decision until transformation. Now, once we kind of do that modeling and we set up the location within our data warehouse, the tables within our data warehouse that we want to load our data lake data into, then it's the process of actually moving the data. In its most basic form, Snowflake does have copy commands that you can use. If your data lake is already in S3, you can likely make your S3 storage available to Snowflake and run copy commands against files in order to load that data, from S3 into the Snowflake tables that you've set up. And Snowpipe, as an extension of that, allows you to run, programmatic Snowpipe calls to, again, read data from S3 and load that into a Snowflake table. Snowpipe does come with some considerations that are probably worth mentioning. Basically we can use to go ahead and ingest S3 data into a Snowflake table. And then another thing to consider is post-migration ingestions, right? So if this is like a one-time migration, you've got a not changing data lake, we've stopped loading data into it, then once you're migrated, you could be done for that type of data. But in most data lake projects, there is data continuing to be loaded in. And so we also have to consider how we're going to continuously load data after the one-time migration, and what sort of techniques and technologies are we going to use to do so. So that's kind of the general process for this type of migration. I do see a question that just came in about wanting an additional slide for nested structures. It is a very important concept. I'm actually going to show you how Upsolver handles those nested structures and tries to make that process simply, but that's a great idea. We'll look at maybe creating some additional content around, best ways to deal with nested data structures in a data lake to Snowflake migration. So with that said, let's kind of take a look at the process, right? How would we migrate an S3 data lake into Snowflake using Upsolver? And for those of you that are on the call right now, you have two options on how to participate in the rest of today's session. I'm going to be walking you through this live. And so if you want to treat this as a demo, feel free to sit back and kind of watch and see how the process works. For those of you that want to get hands-on in this process and feel like you learn more by doing rather than seeing, we will be providing this in kind of a workshop style content. And we do want to encourage anyone who's interested to follow along, and I'll be providing you all the necessary information as we go through so that you can follow along with the process. Right? Before we jump straight into the workshop, though, I realize that I actually haven't spent any time talking about Upsolver yet. It's very much by design. But now that we're going to get into Upsolver, I'll introduce Upsolver as a self-serve cloud data ingestion service designed for high-scale workloads. Right? So if you go back to some of those polling questions that we asked at the beginning of the conversation, Upsolver is a platform designed to help those of you working with real-time data streams, large-scale data volumes, maybe relational databases with frequent changes occurring to them, and those types of data sets needing to be ingested into a data lake or data warehouse for analytics. That's kind of the Upsolver value proposition. And you can see in the lower right-hand corner, our customer base kind of proves out that value at scale, right? Customers that manage megabytes worth of data or are working with data just from a few small-scale SaaS endpoints, probably not a good fit for Upsolver, but customers needing to process hundreds of gigabytes, terabytes, certainly petabytes of data, that's where we prove out our value. And you can see that the fact that I think it's actually up to 10% now of our customers are processing more than a petabyte of data per month through Upsolver. And more than 50% of our customers actually processing more than 10 terabytes of data a month through the Upsolver platform. So very much a platform designed for scale. And we're going to be working with a fairly high scale data set today, not so much in its overall volume, but in the frequency that it's being updated. So we're going to be working with a streaming data source coming from S3, but new files being generated every minute needing to be loaded into a data warehouse. And we'll show you how we can make that process very simple. So in terms of setup, if you do want to follow along with the workshop, if you do have two monitors, I recommend you make sure Zoom is on one of the monitors so that you can follow along with what I'm showing, and then have a browser open on your second monitor. You can use any browser you'd like. Chrome works well, but any should work. The Upsolver interface is all delivered through the browser, so we'll be providing you with details on how to run through the workshop in that browser. And there's two things we're going to do as a part of this workshop. We're going to sign up for an Upsolver account that runs in our cloud platform. And then we'll need a Snowflake account. If you have your own Snowflake account, you might want to get the details of it together. We just need a host name, a login, and a password. And if you'd like to migrate some data into your own Snowflake deployment, certainly want to encourage you to do so. We will be providing a workshop Snowflake account, though, for those that don't want to use your own. And I'll provide details for that here in a few minutes. So the first step of the workshop is to go ahead and get signed up. I'm actually going to send this sign up link through in the chat of Zoom. So it's a pretty simple URL, but if you navigate to that URL that I just sent in the chat of Zoom, that'll get you to the sign up page for Upsolver. And I'm actually going to do this myself as we follow along. Signing up for Upsolver is as simple as giving us an email address and a password. We don't need any more detailed contact information or billing information or anything like that. If you already have an Upsolver account, if you're a production customer or have already been through other workshops, I do recommend creating a fresh account. You can do that by using this plus syntax at the end of your email alias. So I can, for example, say Jason Hall plus migration at upsolver.com, and that'll give me a fresh account that I can work in. Just make sure that we don't have any conflicts when we build out the connections that we need. All right, so signing up is really just that simple. Give us a login and a password, and that'll get you into the Upsolver platform. And this is now running in the Upsolver cloud infrastructure, and we can use this to evaluate or test out or kind of sandbox inside of Upsolver. Now, once logged in, you'll see you're presented with a screen here that prompts you to ingest your first data set. Right, so that's what we're going to do. We're going to ingest our S3 data and write that into Snowflake. So if you click on that button there right in the middle of the screen, you'll see the option to select your source and target. And again, we're going to be reading data from S3. We have an existing data lake stored on S3, and we're going to be writing that data into Snowflake. So choose that as your source and target and click the next button in the lower right-hand corner. There we go. Zoom back in again. Now, the wizard that we use to set up this ingestion has three parts to it. The first part, we're going to set up the connection to our source, right? So this is our S3 data lake. And I'm going to go ahead and share out a slide deck with you. It'll just make things a little bit easier to copy and paste. And I'll actually refer to that slide deck a few times as I ask you to copy and paste certain things into the Upsolver UI. So you'll see that in the chat of Zoom. That's access, basically a read-only copy of the slide deck that we can, you should be able to copy and paste things out of. But if we jump back into the Upsolver UI, we're going to create our connection to S3. You can start by giving it a name. I'll call this Upsolver S3 Workshop, is a good general name to use. And the way that we authenticate to S3 is by using an AWS role. So if you go into that slide deck and look at slide 20, I believe it is. Yep, slide 20. You'll see an AWS role that you can copy and paste into the Upsolver UI. All right, so grab that AWS role there and just paste it into the role field. It should start with ARN. It should finish with Upsolver sample roles, just to make sure you grab the whole thing. And once you paste that AWS role in, you can say test and continue, and it'll verify connectivity. You get the green checkbox telling us that the connection was successful, and then we can proceed. Okay. I see a question. Somebody said they don't have a continue button on the screen. The next button is always in the lower right-hand corner. If you've zoomed in on the browser, it's possible that it's just fallen off the bottom of the screen. So maybe just check your browser, zoom out to back to 100%. You should see the next button in the lower right of the screen, and that should allow you to continue. So we've now got our S3 connection created. And now we just have to select where our files are that we're going to be ingesting from. So this connection has access to a few different buckets. We're going to be working with the Upsolver samples bucket. And inside of that Upsolver samples bucket, there's a few different folders. Welcome to use any of them, but I'm going to recommend using the orders with evolution folder. It has the most interesting data to work with. Okay. So if you click on orders with evolution, now the content type within that location is automatically identified. If you're curious, you can click on the text that says automatic, and it'll show you the different file formats that we support. Most data lakes that I've come across are either in Parquet, Avro, or JSON, but we can work with more or less any type of file that might exist inside of your S3 location. In this example, they're actually JSON files, but we do support pretty much anything that you would want to ingest that's file-based. And we'll leave the automatic option since Upsolver can automatically go ahead and do that. So our request to go back up to the top, the S3 connections, we really just need a name, and it can be whatever you'd like. And then the role is the only other field you have to add in, and it's the role from slide 20 in the deck. I can also put it in the Zoom chat if that's easier for anyone to get at. So just once you add in the name and the role, you can test and continue. You should get the green check, and then you can proceed into step 2. So we'll choose orders with evolution, automatically identify that there are files in that location. In step 3, this is more of a preview step. So Upsolver is showing you some of the files that it found. And you can see here we have a partitioned data lake by year, by month, by day, by hour, even by minute. right? So if you remember, I referred to this as streaming data, even though it's not sitting on a Kafka topic or Kinesis stream, it is in fact streaming data, and that these JSON files are getting created once per minute. And you can see the partition structure that we're finding files within. Right? And then it's also sampling the events that we found in those first few files. Again, this is more of a preview step. We found 36 JSON events. We parsed all of them successfully. And if you want to scroll through, you can see the contents of some of those sampled events. It's just a verification step. It's helpful to kind of see what the data is within these files, just to make sure it's what we expect it to be. So that's step one in the ingestion wizard. Connect to the source, select a bucket, and preview that there are files, and preview the basically preview the events themselves. Okay, I'm just seeing some feedback. Someone is getting a message about an AWS key required. You shouldn't need a key. If you give your connection a name, the authentication method should be role-based, not access key. That's the default, but maybe that was changed by mistake. So make sure the authentication method is set to role-based, and then the only field that you should need to enter is the AWS role. The external ID is hard-coded. It's based on, you'll see something unique to your account, but that's automatically placed in there, and then you should be able to click test and continue. So as long as you didn't change any of the authentication mode or encryption key parameters, you should only need to include the role. All right, so let's go ahead and click next. Hopefully that. Okay, I see someone still struggling. I might have to work with you offline. We can maybe set up some, or maybe, I don't know, go back to the, you can, if you look back in the slides, there are some screenshot examples that kind of walk you through what's needed and what the default parameters are. But hopefully it's an isolated issue or just something specific to what you're trying to do. Right? But so step one, again, give the S3 connection a name, name it, paste in the role. That should be all that we need. So orders with evolution, and just verify that we can find files and successfully parse them. If we click next, now we have to define our Snowflake connection. Okay. So the Snowflake connection details you can find on slide 22. If you look at slide 22 here, again, you're welcome to use your own Snowflake connection, in which case you can reference the connection string as you see defined. If you want to use our own connection details, you'll see a host name that you can copy and paste into the Snowflake connection details. Okay. So we'll paste in the Snowflake connection string. It should start with JDBC and end with public_WH. The username, you can paste it out of the slides if you'd like. It's workshop_November. And the password is Data Lake 1115 with capital D, capital L. So again, probably easiest to just copy and paste that into the form. And then give your connection a name. All right, and I'll call this for now Upsolver Snowflake Workshop. And like with the S3 connection, you should be able to click the test and continue button. Should hopefully test OK for you and get the green checkbox. And then we just have to define a schema and a table that we're going to be loading this data into. Right? So we'll select the sandbox schema. And I recommend creating a unique table name. This is a shared environment. I don't want anyone to kind of overwrite each other's tables. So I often will recommend just put your name at the beginning of the table that you define. And if you have a common name, maybe your initials or just something that will be uniquely identifiable. And I'm going to call this orders data lake migration. Right. So again, just give your table some sort of unique, meaningful name that you're going to write into. Now, if we click next here, the last step of the wizard is to set up the ingestion itself. Right. And there's a few properties that we'll walk through here on this ingestion screen. The first is how often do we want Snowflake to be updated? This is less relevant for a one-time migration, but certainly for continuous or streaming migrations, this is going to define how often we're updating our Snowflake target In other words, how fresh is that data going to be with newly ingested data? Once per minute is the default, but if you don't need minute by minute updates, you can certainly scale that back. And if we're reading from a streaming source or we have new files that arrive in S3 that we want to ingest into Snowflake, think through how often you need that data to be updated, and you can set the interval accordingly. If we keep scrolling down, you'll see, for example, a timestamp field. Upsolver is going to add a timestamp column to every row that we write into Snowflake that allows you to have strong ordering of incoming data. This may be redundant with some existing timestamp fields, but it's a especially good option with streaming data to guarantee that you have an incrementing timestamp with every row, and that allows you to create incremental transformations against those Snowflake tables. All right, so if you want to add that timestamp, that's the default behavior. Here you can see we have the option of preventing duplicates. Duplicates can be a challenge to work with, especially with file-based sources. I've seen a lot of examples where the same data is written to multiple files, or even the same file is written twice with a different name. And you might want to prevent duplicates on ingestion by simply specifying a deduplication key and then defining the dedupe window that you want that to be unique over. So in my case, I've got order ID as a key field, and I'm going to make sure that if we get duplicate events, we're only writing one order ID per minute into our Snowflake table. And then lastly, you'll see here we have a schema configuration, right? The default behavior of this wizard is to write everything into Snowflake in its raw form, right? Everything we see in the source, right into the target. Now notice, we don't have to manually define any schema mapping. Right? Everything's automatically created by Upsolver in the target as it's ingested, right? So we don't have to modify or map any of our schema, but we can choose to if we'd like. For example, there might be some sensitive data inside of some of these fields that we want to hash as it's being ingested, right? In other words, we don't want to write email addresses in plain text. Let's apply a hashing function to that. Maybe there are columns we don't want to write at all. Right? We've got some PII in the source data. We have no need to load that into Snowflake for analytics purposes. So just simply redact that data by deselecting it in the UI. You can also do things like set expectations, right? If you have fields that you expect to never be null, you can set a not null expectation on that field and then either generate a warning or even discard the row if there's a null value within the column that you're ingesting. And so you can set up some of these schema modifications during the ingestion process if required, right? If you want to load data in its pure raw format, just leave everything as default. But if you want to do some schema manipulation or transformation, you can apply that here through the wizard. Now, once we finish those 3 screens in the wizard, there's some very simple code that's generated, right? And the first 2 lines of this code are just to create the connections. Since this is the first time we're building out this ingestion pipeline, we first have to create the connections. You can see connections are created using very simple syntax. And then starting at line 11 here, you'll see the ingestion code itself. And everything that we defined through the wizard, from the interval that we're writing data to the deduplication logic, excluding columns, transforming data, setting expectations, all of this is defined through very simple configuration code that is going to look and feel much like a SQL command that you might run in any number of environments. And I'm going to go ahead and just run this within Upsolver, but you can take this code and further modify it within Upsolver itself, or you can also take this code in varying formats and run it through a CLI or an SDK. We have DBT plugins for those that leverage the DBT ecosystem. So a very flexible interface for managing Upsolver operations through the no-code-based wizard or a very simple kind of low-code experience. But I'll go ahead here and I will create the pipeline or create the ingestion. We can see that everything was created successfully. And there's a link here to monitor that job's progress. Right? So if you click on that, that'll jump us straight into the monitoring interface where we can start to track the progress of data that's being ingested into Snowflake. I'm going to go ahead and pause here and launch a poll. I just like to kind of do a quick spot check to make sure that folks have been able to follow along. Hold on, let me get the polling interface to where I can launch it. There we go. And I'm going to go ahead and just launch this. Hopefully, most of you are staring at the same screen that I'm staring at right now. All right, you've got job monitoring open. You're kind of waiting for data to be ingested, but you've been able to get all the way through the wizard and are, kind of waiting for data to be processed. Right? It looks like so far that's a 100% success, so that's a good sign. All right, cool. So thank you for answering that poll. We've got 100%, so that's good news. All right, so this screen will automatically refresh as we leave it open. If you're impatient like I am, you may choose to manually refresh the screen, but what we should start to see as data begins to ingest is we will see files first be discovered. That's basically we're finding files in the source S3 bucket. We then start the process of parsing those files to determine or inspect the events that are contained within them. And then we'll eventually start writing that data into the Snowflake table that we've defined through the ingestion process. This normally takes a minute or so to start up. Now, as we kind of watch and monitor the status of this ingestion, if you scroll down, you'll see we're going to give you various trend graphs that will show processing delay over time and throughput. We'll show you the number of events that are being handled, the utilization of your compute clusters, as well as any errors that may have been received as a part of this ingestion process. So if there's something we can't parse in a source file or some connectivity failure, you can do all of your troubleshooting and debugging right from the Upsolver UI. And this type of observability is very much a strength of the platform when compared to some alternatives where you just kind of have to set it and trust that it's working. With Upsolver, we give you lots of visibility into the health of the ingestion process, and we can track that either for just kind of confidence that things are working as they should, or in the event that something's not working, you'll have lots of information at your fingertips to diagnose and debug a potential problem. So we can see so far, we've discovered 4,000 files in our source data lake. We've started to parse. We've parsed just over 1,000 rows from within those source files. And once the parsing is complete, we will start writing those rows into our Snowflake table. All right. So this is kind of pipeline observability, as I like to call it, right? The status and health of the pipeline. Now, the other type of observability that Upsolver provides is into data quality, right? So not just the data ingestion process, but what is the data that's being ingested? And we can view that here in the datasets section of the Upsolver UI. All right, it might take a minute or so on your environment for this to be fully available, but once it is, and you click on datasets, you'll now see that Snowflake table that we're ingesting data into. Right, and if you highlight that table, we can start to see some information over on the right about the data that we're ingesting into that table. All right. Just some high level, how many fields have we found? How many rows have we written? This will fill in over time, and eventually we'll start to present a timeline, right? We've just set this up, so there's not much time to show, but after this has been running for minutes, hours, days, you'll see a timeline of row processing. But if we scroll down, you can see the schema of the data that we're ingesting into Snowflake, and all of this was inferred. Remember, when we set up this ingestion, we didn't define any of this mapping. Right? It was automatically set up for us. Here you can see all of the source fields from our data lake files, and all of their data types were automatically inferred. Some of this data was actually nested. Notice this customer field is nested. We've got customer.address.address1 and so on. So Upsolver has automatically parsed and processed this nested data for us. We've inferred the data type. We're telling you how dense the data is within that column. 100% density means that every row had that column defined. In other words, was not null. For anything that had null values, you'll see a less than 100% density. That could indicate a data problem, or it could just be the way that the data is in the source, but it's usually helpful information to know. In the top values column here, you can see the top values from within that column. That can be helpful for inspecting maybe some quality issues. Maybe you find some values that you didn't expect within this source data. If you keep scrolling to the right, you'll see the number of distinct values, especially useful for dimension fields, where you expect maybe 4 values. You can verify whether or not that's the case. And then if we keep scrolling to the right, you'll see timestamps. Now, right now, these are all the same timestamp because we've just started this ingestion. But as we continue to ingest data, and maybe as the schema evolves over time, this will be really helpful in understanding when we first saw data within that column and when we've last seen data within that column, right? If a new column starts to show up in our source, we can see the exact point in time when that new column appeared. If a column name was changed, we'll see the last point in time that the old column was used. We're not going to talk about this on today's workshop, but Upsolver also has data transformation and data replay capabilities. And these timestamps are really useful for those replay scenarios where you might need to re-ingest or transform data from a specific point in time. Knowing exactly when the schema evolves will help in those scenarios. It also just can be useful if you need to go to the upstream data teams and say, as of November 15th at 1:51 in the afternoon, I saw this new field show up. Tell me about that, right? When, why, and when did that happen? And you can use that for debugging or diagnostic purposes. Now, you'll also see all of these column names are hyperlinked. So if you take a column like customer.address.state is a good example. We also give you lots of useful column level details. So for example, nothing at the start is looking concerning. We've got 100% density of the customer state field, 44 distinct values. We know there are 50, maybe 51 states, depending on how you classify certain things. So that doesn't look concerning. Some of the top values, these all look like valid state abbreviations. So that's fine. But if you look at the string length distribution, right? United States addresses, the state field should never have more than 2 characters in its abbreviation. Notice that the min is 2, that's expected, but the maximum string length within that field is 13. That doesn't seem right. Maybe some users are spelling out the state name instead of abbreviating it. And we can see down below, 1.2 thousand rows have a 2-character abbreviation, but there are 3 rows with a 6-character, 5 rows with a 9-character. We've got some data quality issues here that are becoming clear because of the string lengths that we're ingesting. And if we scroll down in the top values list, we can even see what the distribution of values is, right? And notice we've got a state of Elizabeth and a state of Front Royal showing up in a certain percentage of our rows and events. So we clearly have now a data quality problem. It's not just somebody spelling out the state. It's we've got things in here that aren't states, right? And the earlier we can fix this problem, the better. We can go back to the data team, or maybe we can fix this on ingestion through a transformation of some kind or some expectation that we set. That's out of scope for today's workshop, but something that you could consider as a data problem that Upsolver can also help you to address. Okay. So what we've shown you here is really, again, data observability, right? So observability into the pipeline was in the job monitoring. Observability into the data is in the data sets view, and lots of really helpful information as we start and continue to ingest data into your data warehouse. Normally, this sort of activity would happen from the warehouse itself. We'd have to go into Snowflake and run a bunch of queries against our data warehouse tables to see this sort of information. Upsolver makes this readily available in the ingestion process through the datasets interface. So that's the use case that we wanted to highlight during today's session. I will leave you with, and we'll end today's session with kind of where to go for more information. There is a really useful help interface in the Upsolver console. You'll notice a question mark button in the lower right-hand corner. There's also a resources tab on the left. And we've got lots of documentation that you can search through. If things aren't working as expected, there's a contact support button. If you're getting errors that you don't understand, there's also the ability to ask us on Slack. We have a Slack community that anyone can engage with, a great place to access Upsolver resources and customers and ask questions. You're also welcome to reach out to me directly, jasonhall@upsolver.com, if you have questions or comments or need help with any specific scenario. We would love to help you all connect to your data as well. All right, so this workshop went through some sample data that we worked with. We have a data lake that you've been working with. If you have your own data lake or your own files on S3 or your own streaming sources or your own databases that you want to work through the Upsolver platform with, whether that's to ingest into Snowflake or a data lake or some other potential target, please reach out. We'd love to help you. The survey that opens when you leave the meeting will give you an opportunity to tell us if you'd like some help connecting with your own data. And if so, again, we'd love to help with that. You can actually connect to your own data from the environment that you currently have spun up. So there's lots of options, and there's some templates within that platform that can help you with that. Or we can also deploy Upsolver into an AWS account. Many of our production customers will actually deploy Upsolver into their own AWS account. It's a more secure option. You've got more controls over the processing of data, and it's generally considered a more secure infrastructure as well. There's a cloud formation process for deploying Upsolver within a VPC, if that's the option that you'd like to consider. Last thing I'll leave you with, and then we can, I'll look for any last questions that have come up, is we do encourage everyone to follow us on LinkedIn. LinkedIn is generally what we use to broadcast all of our Upsolver specific updates, whether it's new product functionality, new webinars that we're doing, new events that we're hosting, new workshops. So there's a link there to follow us on LinkedIn, or also a QR code if you'd rather follow us on mobile. But customers always ask kind of what's the best way to follow and keep up to date with Upsolver and kind of the comings and goings of the company and the product. And LinkedIn is a great place to follow along with what we're working on. Okay. So I think I've answered a lot of questions just as we've gone through. I don't see, actually, there's one question that is worth answering. This actually comes up fairly often. I did allude to Snowpipe as an option for ingesting data into Snowflake. And the question was kind of like, how does Upsolver compare to Snowpipe? It's a long answer. So I know we're already over the top of the hour. Rather than answer it live, I'm actually going to just send you a link to a white paper that we wrote on this exact topic. I'm going to put it in the chat of Zoom. And it goes over architectural differences between Upsolver and Snowpipe, and also just what are the use cases Snowpipe's designed for, and what are the use cases where it falls short, and where might Upsolver fit in. I mean, in general, Upsolver is a more scalable, more cost-effective ingestion platform, and especially when we're talking about high scale and streaming real-time data. Right. So again, obviously a big topic there, kind of the Snowpipe question, but hopefully that white paper will answer the question for you. Somebody had commented that the QR code is deactivated. Thanks for reporting that. I had not realized that. I'm going to send a link directly to our LinkedIn page for those that might want to follow us on LinkedIn. I apologize for the QR code not working. Let me just, copy the link, and I'll paste that in for those that might want to follow us on LinkedIn. All right, so I think that's all the questions that I've gotten. I do appreciate everyone's time and attention today. I hope this format was useful to you folks, the kind of webinar combined with workshop format. If anybody does have any questions after we wrap up the call, feel free to reach out on Slack or reach out directly. I'd love to work with you further. And again, when you leave the meeting, the survey will pop open. We definitely love any and all feedback. And if anybody would like any assistance in continuing to work with Upsolver or explore additional use cases, we definitely love to take that opportunity to work more closely with you. So I appreciate everyone's time today. Hope you all have a good rest of your day.